Hello everyone, my name is Alex Rosa. I am a postdoctoral research associate at the University of Wisconsin-Madison, and the work that we are going to present is entitled Response of Putative Glyphosate-Resistant Horseweed Accessions from Wisconsin to Spring Burndown Herbicides. Many of us are quite familiar with horseweed in the Midwest of United States. Horseweed is an ideal weed for corn soybean cropping systems. Just because it's a winter summer annual, it has a window of emergence that can start in the fall and continue in the spring. Produces a lot of seed. There are reports that show that horseweed can produce up to or even more than 200,000 seeds per plant. And those seeds, as we can see in the picture here in your left, are really tiny, which facilitate its dispersal by wind or by implements or even people that visit fields. So this facility to get spread out uh, makes this weed a problematic in the whole Midwest of the United States. One alternative that producers find to control this weed is tillage, and particularly in Wisconsin, the tillage is a very common operation in the fall, uh, mostly because of the amount of residue, especially by corn. So producers tend to do tillage and reduce that amount of residue for the following spring. And that operation kind of helps horseweed to stay away or reduce its pressure as compared to no-till. But as we know, no-till is becoming more familiar. Producers are adopting more conservative managements with the introduction of cover crops. And actually, a survey that our group conducted just confirmed what I'm saying to you here, where the majority of producers that were surveyed in 2018 responded that they till. Actually, 230 farmers out of 550 responded that they till. And to give you a perspective how horseweed is inserted in Wisconsin cropping systems, actually is not one of the most common so far. We see here in the graph that giant ragweed and water hemp are more problematic as of now, but horseweed is becoming, let's say, the fourth or fifth place, calling the attention of producers as they switch to tillage to no-till. And also this horseweed becoming problematic because of glyphosate resistance that it's developing in Wisconsin. Not only in Wisconsin, but several reports of resistance throughout the Midwest. So basically, this new cropping system that involves no-till and glyphosate application is the perfect scenario, let's say, for weed resistance to happen. So as we anticipate this scenario where horseweed becomes a common problematic weed in Wisconsin due to the transition to no-till and reliance on glyphosate applications, we ask which available chemistry can be effective to provide a satisfactory control of horseweed besides glyphosate, right? So with this study, we hypothesized that although several burndown herbicides are still effective to control horseweed, some populations are developing resistance to the most common herbicides used. Therefore, the objectives of our research is to investigate the efficacy of commonly applied burndown herbicides for horseweed control. The study was conducted at the University of Wisconsin-Madison, in the greenhouse. We did 2 runs of this experiment. The treatments were 10 Burndown herbicides plus a control, and 21 horseweed populations from Wisconsin and northern Illinois. The herbicides were applied when horseweed reached 9 centimeters or 3.5 inches, and also they were sprayed at label rate. Only glyphosate was sprayed at 1 and 3x the label rate. Horseweed control ratings were evaluated at 7, 14, and 21 days after treatment. Those visual ratings were ranging from 0 to 100%, where 0% means no control and 100% means full control. Also, in the end of the study, we collected horseweed biomass, and the experimental design was a completely randomized design with 6 replications. The statistical analysis was done in R. We conducted ANOVA in the beta distribution using the function glmtb in R. The horseweed populations were collected in soybean fields, and they were sent our way by agronomists and producers, besides the one that we collected ourselves. We then asked for the accurate location of those populations so we could plot them in the map and know how well spread they are in the states. The populations were grown in the greenhouse where we put them in trays to germinate, and after we transplanted to single pots before we spray them. The herbicides used in this study were glyphosate at 1 and 3x of the label rate, imazethapyr, mesotrione, atrazine, 2,4-D, dicamba, glufosinate, saflufenacil, and paraquat. We also have the application rate here in the table in the imperial system and also in the metric systems. The herbicide application information, we used 140 liters per hectare or 15 gallons per acre. The herbicides were sprayed at the stationary spray chamber, and the growth regulators were sprayed using a backpack sprayer. So, talking about our results, this is a graph of horseweed control at 7 days after treatment. We have in the y-axis the herbicides that we tested, in the x-axis the horseweed visual control in percentage. And as we can see in this first graph is that paraquat, saflufenacil, and glufosinate, by 7 days they already had a really good control on horseweed overall, okay? And the same story as the time passed by, we add atrazine to that package, so saflufenacil, paraquat, glufosinate, and atrazine with a really good control. The other chemistry a little behind. As we move further with 21 days after treatment is when we actually finish the study, we will know that a few of those chemistries tested did not reach 90% of control, and those include 2,4-D, glyphosate, and imazethapyr. The biomass reduction confirms our findings in the visual. The only difference is 2,4-D that got a satisfactory biomass reduction. And here I have a time lapse, so you can all check it out how the symptoms develop. We had this time lapse from 0 to 15 days, or 1 day after we sprayed until 15 days, and it's really neat to see all the herbicides acting in this time frame. Those are the commercial names, Pursuit being imazethapyr, Atrax atrazine, Sharpen is saflufenacil, Liberty is glufosinate, Callisto is mesotrione, Gramoxone for paraquat, Enlist 1 for 2,4-D, Stanimax for dicamba, Roundup for glyphosate. Pretty neat. And when we look at the populations, all the 21 populations tested across the state, What really called our attention is the fact of 2,4-D lacking of control of four of those populations, basically 1, 2, 20, and 21. Likely the cold weather when we sprayed this herbicide, that was already October and November. So the cold weather likely reduced the efficacy of 2,4-D. And with that, we believe that those populations will need further evaluations before we make any inference. This table summarizes our whole study, and it's interesting to note that glyphosate, imazethapyr, mostly those two herbicides, they really had a poor control in overall and also when we look at population. So more than 60% of those populations are not being controlled by those chemistries. Even imazethapyr, even worst case scenario, none of the populations were controlled by imazethapyr. And like I said, 2,4-D, we need to further evaluate. And the maps, we plotted the maps, the Wisconsin map with the populations and their respective resistance, let's say, to each of those herbicides. This first map is glyphosate. We can see that glyphosate is pretty spread out in this state. Now, imazethapyr, none of the populations were controlled. We have a blue dot that we didn't test the population. That's why you see that. And 2,4-D with four of the populations not being controlled by 2,4-D or not having a satisfactory control by 2,4-D. Now, as final implications of our study, we found that saflufenacil, glufosinate, and paraquat had the fastest and greatest horseweed control. Now, at 21 days after treatment, only glyphosate at both 1 and 3x and imazethapyr did not provide a satisfactory horseweed control. And the lack of effective control, and by means more than 90%, happened in 19% of the population screened with 2,4-D. So further evaluations for 2,4-D will be necessary. Interesting to note that 65% of populations screened were not controlled by glyphosate and imazethapyr. And the potential horseweed, glyphosate, and imazethapyr resistance are well spread across Wisconsin and northern Illinois. Future implications include dose response analysis and molecular investigations of some populations to glyphosate, imazethapyr, and 2,4-D. I would like to acknowledge our team for the hard work that everyone have been doing. I would like to thank the producers and agronomists that sent our way horseweed seeds, much appreciated. We would like to acknowledge the United Soybean Board, the Wisconsin Soybean Marketing Board, the Wisconsin Corn Board as well, and the Take Action Herbicide-Resistant Management for all their support. And visit our webpage, WiscWeeds.info, and also our YouTube channel, UW-Mad About Weeds. Thank you very much for your attention.